Welcome everyone. Myself Vasan. So I have 8+ years of experience in IT. I also hold 5 cross AWS certified plus Terraform associate level certified. In this session, we will be covering Terraform module and its best practices. I also run two YouTube channels. One called Tech Page, which is all in Tamil, and the another one it's called evidhai, which all in English. In both, I talk about the technical stuffs on AWS, Terraform, DevOps, and more on the IT related skills. So today for the agenda is we'll talk about what is in Terraform, what it's meant to do, and how it can handle or help us in handling the multi-cloud ones, and how can we write a custom module for our own need, and also using the best practice like don't repeat yourself concepts as part of the module. So to start with, the role of Terraform is it's going to help us to achieve the infra as code. So you need an EC2 instance, you need an S3 or any infra component, and if the service or the service provider is helping you to provide you the Terraform oriented providers, then we can able to achieve the infrastructure as a code with the mean of Terraform. So why Terraform and why not any other equivalent like CloudFormation or alternative? So the Terraform is like easily supports multi-cloud. So in case if you want to build a hybrid architecture, or in later you want to move from one cloud provider to the another cloud provider or any such scenarios, it's easy to handle such occasions. It's not just limited to cloud, even other non-cloud provide services like Cloudflare, Akamai, and many more offers the Terraform provider service, which at the backend uses the Go language and talks with the relevant or respective APIs to get the infra as code achieved. The infra as code makes multiple cloud easy, which we already spoke, and as I already flagged, it's not just limited to cloud. You can also integrate with third-party components like DNS and many more. So how the file structure looks like? So all the Terraform code whichever we write, it's going to be ends with a file name .tf, and all will be enclosed in a single folder. And when we execute the commands of Terraform, it's going to compile all the files. It doesn't matter which order you write. So Terraform is capable of doing that magic behind the scenes to consolidate all the contents within the file, get it composed all together and get it executed. So providers, so this is where the provider blocks which goes inside the file, and many would be already knowing this, where you provide the provider name. So in this case we are using the provider for AWS, and the version of 4.67 we are using it. The one which you see the tilde and the greater than symbol represents like what version we are allowing. So if we just have greater than 4.67, so any version greater than 4.67 it gets supported. If we just mention like equal to 4.67, it's hard coded to the version 4.67. If you say like a tilde of 4.67, then any version within that 4 range gets supported. So in future if something like 4.9, then it gets automatically upgrade to that version. So that's what the version in the provider is meant for. And the source, it says Hashicorp/AWS, which means it's going to use the official version of AWS provider acknowledged by the Hashicorp pack. The 4 basic commands, anyone who wants to learn or want to get the hands-on on the Terraform must know is the 4 commands: init, plan, apply, and destroy. Irrespective of the concepts you came across, these 4 commands is going to come handy in order to create a resource, set up the provider, update the resource, or destroy the resource which we created. Let's see a quick demo of each command, what it's able to do with. So the first one is going to be the init. So init is going to initialize the provider in case if you are using AWS, Cloudflare, GCP, whatever the provider you configured as a provider block. then it's going to download those provider configuration locally and get our local setup ready in place. So this is how it's going to look like when we run the command terraform init. It just starts initializing the backend for us, and it's configured the backend S3 in case if you are configuring the state file, the backend S3 state, and that's how the entire configuration works. And you could see it's installing the version 4.67, which is exactly what's been configured as part of the provider block in the couple of previous slides. So once the init is done, the next thing we would generally do is the plan. So plan is going to list down, in case if you are going to apply the changes, what changes would have been done, so that we can review it to ensure that whatever we are intended to do the change, only those changes are going to be occurred. So let's see a quick glance like how it's going to look like when we do a Terraform plan. This would list us three major components: one to add, to modify, and to destroy, so that we can see the total count of each, how many resources would get added, how many resources would get modified, and how many resources would get destroyed. So in this you can see one resources to get added, and there is no change and nothing to destroy from our state file. And also it gives you the resource description added with a plus sign, as you could see in the screen. The next thing would be the apply. In case if you are happy with the plan, then we can move to the next phase of applying, which is exactly applying the change to the backend or to the console, which is equivalent of creating a resource or updating the resource or destroying the resource. So when we say apply, then it's going to ask us the double confirmation of yes or no before applying. In case if you want to like auto approve it, you can also pass the parameter next to Terraform apply command with --, auto approve syntax. So once we give the S, it will be creating the resource. It would have also ran the plan stage again before applying part. The next thing would be the destroy state, which is to destroy the resources whichever already exist as part of the state file. When we do that, whatever the state files are being tracked will be get destroyed. So we could see here the Terraform destroy is a command. In case if you want to destroy specific resource, you can use -target syntax to specifically destroy the resources. In case if you want to destroy any resources which is currently tracked by the state file, then we can use Terraform destroy as part of the command. So this is going to take the few minutes of time, the destroying, because it should do all the backend work of communicating with the API and then listing down, and again it asks for us a permission like yes or no, and once we given that, then it's going to do the destroy of the resources which is going to be get tracked over there. So this is the basic fundamentals which you would need to know as a beginner, like how the Terraform is structured and what the provider block is for, and what are the basic commands that would help us in terms of getting the resource deployed, and in case if you want to destroy it, what are the commands we would need in real-time place. So here, as you could see, like since I gave the S command, it started destroying. Also it gives us the what resources is getting destroyed and how long it's going to take time. Those also being displayed right in front of the screen. So we could see the console response. It's totally destroyed the 3 resources as part of the destroy action. Before jumping into the module, the another thing you would also need to know is the variable component. So the variable makes our Terraform module more dynamic, so that we have the flexibility to modify the value. It can be any resource name or a parameter at the runtime of the Terraform. So we will see the generic syntax of the variable. So this section will talk about the Terraform variables part. So this is the generic syntax. So you start with variable, and then within double quotes you give the variable name, and then the type, default, and the description. So that here within the blocks it's going to be optional. So when we say default and value, then you can skip the passing of the variable at the runtime, or if the default value is missed as part of creation of the resource, then it's mandatory for the user who is assessing our module to pass the variable value at the time of creation. So the types field, the one which you see here in the screen, supports, these are the values. It supports string, number, bool, list, set, object, and tuple. So string we generally list down within the double quotes, number is just number, bool it's true or false. The list is more like a set of objects, or the within the double quotes or the square brackets, and sets would be in the curly brackets, and objects would be in the object name followed by the value. So we will see how it is done or how it's handled in real time of a code in the upcoming slides. So this is a generic syntax, how it looks, and what are the types of the variable. You could see like string, how it looks, number, boolean, list, map, null, and other types. If you want, you can take a snapshot of the screen for further notes. In variable, we can also attach the validation part. So the validation is going to give us the to ensure only the expected or the patterned values passed to the module. For example, here we are saying for a variable of AMI, the AMI ID, it should be like greater than 4. So if anything is less than 4, the validation is going to fail and it would throw us the error. Maybe we can configure it as like AMI should be of minimum of 4 letters. So this can be really helpful by using the combination of Terraform inbuilt functions. Let's say you have a custom saying that any resources should have an environmental ending. It should end with an environment type like a prod or non-prod. Then you can say like it should contain or it should ends with in the name, to ensure the common best practice within your company it's been followed when we still enable the dynamical approach of letting the users to pass the value, and we also ensure the naming pattern or the expected value standard is being maintained as part of the module creation. So at the runtime, the variables could able to be passed in like multiple options. One, it's in terms of while applying, we can say Terraform apply and then var equal to with the variable name followed by the value. So here the image underscore id is the variable name, and AMI and -abc123 is the value for it. There is one more value which is, you can, if you have multiple variables, you can add those variables as a file, either as a tfvars or tfvars.json, and then during the runtime we can pass as -var -file equal to the file location. So here I'm having the tf.vars locally, so I just direct pointed the file name. You can also use to pass the relative path of it, so that even if we run it in a centralized location like a Jenkins or a GitHub Actions, your file is getting fetched from the right place. The option 3, it would be the environmental variable, where you can set the environmental variable begins with tf underscore. So in case if our variable name is image underscore id, then we would set the variable, the local environmental variable as tf underscore var underscore the variable name followed by the value, so that when we run, when we apply, it's going to automatically fetch from the local variables. So now you might be having the question, hey, there is a multiple ways to pass the variable at the runtime. What if I pass the same variable with a different value in multiple ways at the time of creation. For example, I can say tf underscore var image id equal to x, and I can store the tf dot vars file with the same image id into y value, and also at the run hyphen var as a parameter and say image underscore id equal to z value. So the same variable we are trying to pass in a multiple values during the runtime. So how Terraform is going to handle that? So if you ask me that question, so Terraform gets you covered. So we call it as variables precedence. In this case, when the Terraform is trying to get execute, first it's try to get the value of environmental variables, and in case if you also have the environmental variables and tf.vars or tf.vars.json file, then those values is going to override your environmental variable and followed by the hyphen var or hyphen var hyphen file, as you could see in the screen. So this is how the precedence is going to work. So the default, it's going to take the tf vars, the environmental variable, and it's going to get overridden with the tf.vars file and then the hyphen var which you are going to configure it. So far we have talked about the more theoretical part. So now let's go into the part of how the module would be written and what are the best practices should be get configured. So the structure wise, this is how it generally looks. So you would be having a module all separated in a folder, and here we see an option for like EC2 as a separate module and SG as a separate module, so security group. So I'm taking AWS as a reference to see how can we build the module from that one. So the module is more like template. So let's say you want to create a resource, but you want to create n number of resources in multiple places, and if the developers is not good enough in Terraform, but they just want to create a resource and also you want to maintain some standard, so you let developer to pass the minimum input to while creating the resources, and the module which you create, it's going to take care of the backside magic of the resource creation without overburning the one. So the first best practice when we talk about creating the module itself is to create resource specific module, and then you can combine more than one module to build your own custom use case if you have any per application specific, so that we can focus on one service. If there is any update from the Terraform provider for a X service, then we can just update the specific one with a major or minor version based on the update without impacting the wider scope. Also, there can be a scenario if we combine multiple modules all together or multiple resources into a single module as a base, then we enforce to create all resources at the same time. For example, if you are combining EC2 and SG as a single module, as a base module, then if there is a requirement just to create a security group, you end up creating the EC2 as well, since it's both are integrated all together. Whereas if it's been both are like segregated into two different modules, then we have the luxury to create n number of SG, n number of EC2, and we can combine those modules and create a resource altogether as per our business need. So the module can be sounds fancy or sounds complex for few, but it's as simple as it is, as if you just create a resource in the real world, but just that we make it as dynamic we could from our end. So here you see the folder called SG, which is a module which I already created for you to create a security group for us. So the security group, it's, as you could see, it's just as if it's creating a resource itself, and you see like resource and the resource block, the resource type which is a security group, and the resource name which you get for it, and then I'm creating an ingress block of port 80 and 2 port and CIDR blocks. So before writing a module, first we would need to know what are the parameters we are going to expect from the user, and that can be the parameters, few parameters which are like optional, and few are mandatory from the resource or the provider end. So how can we know which is expected, which is not expected, and what its type? Is it string, list, map? What type of values you would need to get passed through it? So how can I know that? So Terraform is very good in terms of documenting that providers. So all you would need to do is you just go for Terraform AWS providers in Google. Let me bring it to the screen over here, and you see the first one would take us to the providers of AWS provider, and you can go to the documentation, and this gives us the list of services. So for example, we are talking about the security group itself, so I can just search with the keyword security group. You can see under resources there is a resource type called security group. With the list also you can see the provider version. So in our case we are using something around 4.67, and so we can read the documentation specific to that 4.67. And so they also given you the sample resource, like in case if you want to do it at quickly, if I want to try it out, you can just do it with the sample resource. Or if you go deep dive into it, we can see what are the parameters. Also it have a description around it, whether it's optional. So if it's optional, then you can skip it. If it's not meant as optional, then we are enforced to do it. So for example, here the from port, it's mentioned as required state, and if it's required, then as part of the resource creation is a mandatory field. So that would exist in our module as well, because it's primarily we are trying to create a resource and then we template it to create the module out of it. And same way here in few cases it can be kept as optional, which is optional to create a resource but may be mandatory in terms of the use case wise. So you would decide as a Terraform engineer or a cloud engineer, when we try to build a module out of it, we see, okay, is this template parameter or is this specific category is to be mandatory for me or not at the time of resource creation. So accordingly we pick the parameter, the argument reference, and put it into a resource block at first. So now you could see in the Terraform TF resource itself, we have an ingress block with from port and to port and protocol description and things. And here again you can rethink about what are the things I wanted to hard code and what are the things I would let the users to pass. So for example, let's say you are creating a security group module for port 80 to open. So it would make sense to hard code those values 80 and 2 port, so that the user don't want to pass the port because your intention is to open the port 80 as part of the security group itself, and where else you can just let the user to create the CADR block. So you can just convert this one into a variable itself. So that's where the variable kicks in. So you would declare a variable with something around like, let's say variable and then the CADR range, and so the type is going to be list, and if you want you can pass the description value and stuff around that. So I would let you to explore on that part, but you get the idea of how you write the variable. So you write the variable whenever you want to make that specific parameter or argument to be dynamic at the time of runtime creation. So also you need to keep in mind when you create a resource, and if you need a ID of the resource or the parameter of the resource, you generally say like AWS security group dot the resource name dot ID, because it's inbuilt. Whereas when it comes to the module, you would need to explicitly pass the output. So for example, if I need the security group ID of the resource which I'm creating it, then I would need to explicitly say the output block with the naming can be anything, but the standard naming would be that multiple words like underscore. You can come up with your own naming standards, but I generally prefer the resource type, or the resource type and then application type and then the ID, or whatever you would be comfort enough in it. So here we are just passing the ID value as an output, so that in later if you want to fetch the value, we can refer it from the output parameter of the module itself. So here also within the module you will be configuring the provider, because you might be writing the module in some X version, and as the days pass it can still evolve further, and if the syntax change or any update change from the provider block, it can break the resources which is created as part of the module. So generally we tend to restrict the version, like till what version or what provider the module supports. And so here we have enforces 4.0, and so currently the latest one is 5. So in case if you try to assess the 5 version in your stack, then it might not work, since it supports till only 4 as part of the module written. So you would use this Terraform provider block to control what provider version you support as part of your module. So this is something very basic, everyone should know. Then you can call this module in two ways. In case if the module is written within the same repo or same file, then there is one option to do it. Or in case if you are going to store the module in a remote repository, and if you are going to fetch that module at runtime, there is another way to do it. So first I will show you how can you fetch the module if it's in the similar scenario, like within the same repository or same file system. So I have a separate folder called stacks to create the resource which is going to refer the module which we have in place over there. So if you see, I also categorize within multiple folders like .tf and .tf. So at runtime it would consolidate all at once, and you could see if I want to create a resource of security group or a different one, then I would be creating it as a resource security group underscore name and xyz. So rather than what I'm doing here is I'm just using a module block which says module and then any name, and in the source I'm referring to the folder of the module. So in our case it's going to be, I'm using the relative reference, so which means I'm stepping 2 folders away. Like if I dot is for like 1 step away, which comes to the stacks, and then one more dot is for the outside of the website folder, and once then I'm entering into the module and then going into the security group, the SG folder. So that's how you would refer the module, and then I'm passing the security group description. So if you see here, we have declared a variable called sg underscore description, and we are just passing that value as part of the module block. So any variable you declare will be passed within the module block, and that will be stored in the relevant variable. So in this case it would be like stored in the sg underscore description variable, and if you want to refer that within your stack, then you can use it by referring using var dot. For example, I can say that var dot sg underscore description. So in case if I want to refer the variable which is passed from the user, so that's how it works. So all the variables would be passed, or will be like passed as the parameter within the module block over here. So you see already the benefit of module, like I'm calling the same source, and I'm just passing the required values or required variables which is expected. And so this would be the developer's point of view, that they don't need to worry about what resource, what port is being opened. All they would need to just follow this template. In case if I need a new security group for port 80 for some xyz reason, all I'm going to do is just copy the module, and maybe I can rename the version 2. So that's going to create me a separate security group without worrying about this complex security group and XYZ thing. At the stack level, we still need to pass the required provider, the same as how we done in the module block. In addition to that, you can also see we are passing the backend configuration within the Terraform block. So all we do here is saying rather than storing the state file of the Terraform configuration locally, we are just storing it in a bucket name called tp 123456789 under the folder batch2 and the file website. So it's all about we are just storing it in the centralized location, so that if it's going to run in the pipeline or as a DevOps tooling mechanism, whoever runs this repository, they fetch the latest state of the resources and they take it update from there, and any drift in the configuration is going to be reflected when they do the Terraform apply phase to see is the changes expected or not, and the standard process has been followed. So again, the best practice when we do the module or multi team approach is to go with the backend S3 as a state file storing mechanism. So rather than storing the state file locally, it's always wise to store in a centralized cloud storage, so that when we expand the team, maybe today you are just working as a single person, but tomorrow if you are going to expand the team, it comes handy to store it and run. To add more advantage, you can also integrate your DynamoDB table, so that each time a log file is created, and you can ensure like the multiple runtime of Terraform resources is not done when we do that. So also in top of it, like let's say you are creating a resource and you want to rename it once it's created as a resource. Let's say I want to rename from SG1 into, let's say, ABC, for example, post creation of resource. So in general, you would do the Terraform would destroy and recreate it because we are renaming the module. But if you don't want to do the destroy and recreate, but just rename it, then one way would be is to like the complex way of removing it from the state file. You can stay like Terraform rm and then the Terraform state rm and remove it and then re-import it. The simplest way would be to do this, that you can say mood block, and you can see like what are the resources got moved, and you can rename from there. Like for example here, this one would be like we are renaming SG-1, and the resource would be the one which is this one, right? The security group allow underscore 80. So we can say this one is now changed into SG web hyphen ABC. So likewise we can do it so that Terraform rather destroy and recreate it, understand okay there is some renaming of the module happened, but rest everything looks fine. So this block can come handy, and because as the time goes there would be like multiple organization decision would come in picture in terms of renaming the resource, renaming the module. So in such occasion this mode block would come very handy over there. You also have the output. So let's say how to assess the output, right? Like if you see when we create the module, we saw something like output block SG underscore ID. So how can we call that? So the calling would be just the module name, and then the output parameter name. So people generally get confused, like they just call like module dot this one dot ID or something around that, but it should be always the output name which you are passing. So in case if this is not passed, then there is no way to get the details of the resources which are created as part of the module. So that's something we would need to keep in mind whenever we create the module altogether. And one more thing when it comes to the best practice of module is that the naming conventions, you follow the proper appropriate naming conventions, and you categorize the folders. For example, all the security group as a separate file, and maybe EC2 as a separate file, and you can cross-refer the modules and the EC2 reference each other. So these are the basic things which someone should keep in mind. We try to create a module as user friendly as could, with a minimum input expectation from the end user, and we do as much we could. You can also you try to use advanced functionalities like the Terraform inbuilt functions. As such, uh, there are like multiple ones which Terraform offers. Let's say you can find the length of it, which can be used to find the uh, to set the validation basically for the variables. So go through these functions. There are like plenty of things happens which will be like comes handy when we plan to set the environmental variables validation part as an input. So here you can see like ends with, it should ends with some prod or non-prod, such kind of use case. You can use it. You can also try to accommodate dynamic blocks as part of the Terraform thing. Like there is a open source materials where like it makes you things handy. So even the repeated code can be avoided by using the dynamic blocks. So yeah, so we are quite running out of time, but I believe you find this session a bit useful. If you find this helpful, maybe if you want to do a follow-up session required, do let me know. Like I can have a talk and plan for a consecutive series of more deep dive into a concept specific session as such, of maybe dynamic blocks or running the Terraform in deep dive. If you need a real-time examples for the Terraform modules, there is one which I found, the Terraform AWS modules itself, which would like come handy. Like they almost covered all the resources, and you see how to refer it as well, like the source as of this, and the end-to-end configuration is being provided for each and every resources. And there used to be a reference links as well. Let me try to fetch it. Right, so here you have so for example, this one is going to be for the RDS, the open source module, and you can see how each and everything is being configured, and the files being returned with multiple state files, and the best practice for the file naming conventions, and the resource naming conventions, and they almost use like almost all the Terraform functions, and how the variables been handled very nicely. So take any one service and try to see how the modules is written in the open source one. That would really come handy to self learn and evolve. Yeah, so thanks for listening till end of this, and so hopefully to see you guys more soon in more series like this, if any in the future. So do ensure to subscribe for my channel for more updates on the Terraform and DevOps series called evidhai. I'll also ask to post it in the comment section. So thanks you for staying patient, and so see you soon in another video. Thank you guys. Cheers.